Okay, this is understanding integrals, part 2. Okay, and we are going to basically graph this. Okay, so I got a graph, and in this case I have my time and I have my velocity, right? And what I like to do is time on the x-axis and velocity on the y-axis. Okay? So this would be my x and my y, so to speak. Okay? So, we just graph it out. So, I know it's going to 90, and so I'm going to go by 15. So, 15, 1, 2, 3, 4, 5, 6, 7, and I might need a little more. 1, 2, 3, 4, 5, 6. Oh no, that's good. Okay, so I'm going 15, 30, 45, 60, 75, 90. Okay? And then that was my times, and then I'm going, velocity is up, so I'm just going to 12, so I might as well just go 1 to 12. So 1, 2, 3, 4, 5, 6, 7, 8. And this one I need more. 9, 10, 11, 12. So that's going to be my velocity. Okay? Okay, so 1, and then 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11, 12. Okay? So I have them labeled, and now I can just mark them out. So 0, 12 would be my first dot. And just do my dots in red so I can see where they're at. So 12 is there. 15, 11 is there. 30, 10 is there. And then 30, 10 is there. And then 45, 10 is there. Right? And then 68 would be there. And 75, 7 would be there. And 90 and 0 would be right there. Okay? So now I'm going to draw my curve. So here it is. Okay? Great curve. Alright, so now I'm going to kind of put in my simple rectangles. So from this point over, I'm making my rectangle. Okay? And then from this point over, I'm making my rectangle. 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 And from this point over, I'm making my rectangle. Now those are green. So this green is representing my low estimate on the graph. Okay? So if I'm looking at my area of the graph, this green is representing the low estimate. Okay? Now this blue is going to represent the high estimate. What that means is I'm going to come up and over, 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 up and over. Okay? So I'm going to look at this blue like this. Okay? Now this part between the green and the blue, I'm going to look as is red. Okay? Now here's what's going on.
How did you do the 0 and 90?
The 0?
Oh, it's right here, never mind. So it'd be 90 right here?
Yeah. The 0 is on the line.
Right on the line because it's 0.
Yeah, that's 0. Yeah.
Okay.
Because the car is braking,
Uh-huh.
right? So it's coming slower and slower and slower and slower until it's nothing. So it was going 12 miles an hour or whatever, and then it just kind of slowed down, and then it slowed down some more, and then it really slowed down.
Okay, I see what you
Okay? So it's kind of more realistic. Like, you're coming to a stop sign, right? You start to slow down a little bit, right? But then you kind of, okay, you let up off the gas or off the brake a little bit, so you glide a little bit. And that's where this point is. You're doing 10 here. You're doing 10 still here. You know, 15 seconds later. And then you hit the brakes. You know, right when you get up. Now 15 seconds is a long time, but anyway.
It is.
So, now, what we're doing is looking at this as like the area under the curve and a little bit above the curve. Okay? So, our lower estimate of the area under the curve is the green. And so how we find that is we take the width times the height. So the width here is 15. And the height of this green is 11. So it'd be 15 times 11, okay, plus 15 times 10. Plus 15 times 10 plus 15 times 8 plus 15 times 7 plus 15 times 0. Okay? So what we have here is 15 times 11, which is 165, plus 15 times 10, which is 150. Let's make sure we're actually recording. Good, we are. Plus 150, plus 15 times 8, which is 30 less than 150, which is 120, plus 15 times 7, which is 15 less than that, so it's 105, plus 15 times 0, which is 0. Okay? Now we add them all up, so we've got 300, 400, 500, 600, and 85, and 90. So it looks like we got add them up to be, the low estimate is equal to 690. Is that what we got earlier? Hopefully it is. Okay, so now that's our low estimate. So now we're going to look at our high estimate. Our high estimate has to do with these, the top parts of the blue. So this whole piece, this whole piece, this whole piece. So let's start writing it out and see what happens. So our upper estimate is equal to 15 times 12 plus 15, and then it's going to continue. 15 times 11, 15 times 10, 15 times 10, 15 times 8, 15 times 7, 15 times 0. So again, it's going to do all of this, right? So plus, plus our LE. So our upper limit is really that first one plus the LE. So what we're missing here is the combination of the lower plus the higher plus the higher plus the highest. Okay? So what we really have here is 12 times, that's 165 plus 15 is 70, 80. 180 plus 690. So what we really have is 870. Is that right? So our upper estimate is 870. Now, we want to find the best estimate. Now the best estimate is kind of taken, notice how each one of these is kind of cut in half except for this one, and this one, and this one. Our best estimate here is going to be cutting this thing, kind of taking the average between the two. And when we take the average between these two, we just add this plus this and divide by 2. What we're really doing is dividing.
This and divide by 2.
We're dividing this piece by 2 when we think of it, because there's no difference between these except for this, right? So the only difference between this and this is the 180. So really, we're just taking 180 and cutting it in half, and that's 90. So what's 90 plus 690? So our best estimate is going to be 780. Okay? Now, of course, I would go a step further and say, well, getting rid of this block would be good because, you know, that would get rid of a lot more. So that block alone is not even included in the half. So if we got rid of that block, that would be a much better estimate in this case. So my best estimate would be, what is this block? So that's 15 times 10 to 12 is 2, right? So that block right there is 15 by 2, which means that it equals 30, right? So if I subtract this by 30, my better estimate would be 750. Okay? So that's the best estimate I can come up with. Okay? Now, if we were to graph the actual integral of the curve, so if we could put this curve into a formula and then learn about the integral. So in other words, where we're going with this is we're going to be able to take these curves, right? And instead of taking big blocks like this out of it, what if I were to take a microscope and look at this curve? Right now, it looks like this, right? Right here.
Mm-hmm.
But if I took a microscope and looked right here, it would look like this. Mm-hmm. And I took a bigger microscope and looked at it, it would look like this. And a bigger microscope until it was totally flat. And if I got to look at it at exactly 1 point on the line, that 1 point that made up, that would be perfectly flat. So if I took the area underneath that point, right, and then I took the area of the point next to that, and then I took the area of the point next to that, and then I took the area of the point next to that, and I did it all the way through and added up all those areas, I would find the exact area. And that's where we're going to. That's what we're trying to get to. Okay?
Is this what you read already, the tragedy of common?
Perfect.